Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of an oblique line PQ, and in this particular case we have witnessed that points P and Q, they lie in the different quadrants over there. So we are required to obtain the front view projections, the top view projections and the right hand side view projections of this line PQ when point P happens to lie in quadrant number 1 and point Q happens to lie in quadrant number 3. So we understand that whenever a point happens to lie in quadrant 1, the front view of the point, that is P dash point, will be located above the XY reference line, and the top view corresponding to that point, that is point P, it will lie below the XY reference line. Whereas whenever the point it lies in the third quadrant, so the front view of that point, that is Q dash, it will be lying below the XY reference line, and the top view of that point, that is point Q, it will be lying above the XY reference line. So if we join the front view projections corresponding to the points P and Q, so we will find that P dash point will be lying above the XY reference line while the Q dash point will be lying below the XY reference line. This will be an inclined front view projection that we will be getting, in which point P dash is located above the XY reference line and point Q dash is located below the XY reference line. Similarly, if we are going to evaluate the top view projections of this line, so we will observe that point P projection, it will be lying below the XY reference line, while the top view projection corresponding to the point Q, it will be lying above the XY reference line. So joining the top view projections P with Q will mean that point P is below the XY reference line and the point Q is above the XY reference line. So this way we have to plot the projections of the point PQ, and we are also provided with the distance between the end projectors of the line P and Q measured parallel to the XY reference line, and this distance happens to be 55 millimeter. So with this information we are required to draw the front view projections, the top view projections and the right hand side view projections of the line PQ on the common reference lines XY and X1 Y1, and we will also be connecting the respective views, that is P dash with Q dash, P with Q and P double dash with Q dash over here. So let us start with the construction of the orthographic projections of an oblique line PQ, in which point P happens to lie in quadrant 1, point Q happens to lie in quadrant 3, and we have been provided with the distance between the end projectors of the points P and Q measured parallel to the XY reference line. Here we have got XY reference line. Here we have also obtained the X1 Y1 reference line, and we are required to obtain the right hand side view projections of this line PQ. So the right hand projections will be drawn on the left hand side of the front view. So now you can see that since the 2 points, they are lying in the different quadrants, that is quadrant 1 and quadrant 3, so we are not drawing transfer line as usual. So usually we have been drawing transfer line like this in order to be able to convert the distance of the vertical plane from the top view into the profile view projections over there. So since we have to deal with the transferring the distances from the vertical plane into the first quadrant and the third quadrant over here. So this type of the inclined transfer line we are required to draw at an angle of 45 degree with respect to the XY reference line or 45 degree with respect to the X1 Y1 reference line. So this is going to be our unique transfer line which we are requiring in this particular case because we have to deal with 2 points P and Q which happen to lie in quadrants 1 and 3 over here. So let us proceed with the construction of front view projections corresponding to the point P which happens to lie 25 millimeter above the horizontal plane and 10 millimeter in front of the vertical plane. So since this point P, it lies in quadrant 1, so the front view projection, that is P dash, will be located 25 millimeter above the XY reference line. So we have got front view projection P dash drawn 25 millimeter above the XY reference line. The moment we mark the projection of the point P in the front view as P dash, so we know that the projection of the point P onto the top view projections, that is point P, will be lying just below this particular point P alongside this vertical projector line drawn through the point P dash over here. So we know that the distance of the point P from the vertical plane, it is 10 millimeter. That is point P lies 10 millimeter in front of the vertical plane. So this 10 millimeter distance will be drawn below the XY reference line because the horizontal plane will be rotated in the clockwise direction. So the distance in front of the vertical plane will be located below the XY reference line. So with this, we have been able to plot the front view projections, that is P dash, and the top view projection corresponding to the point P. So another information which is available with us, the distance between the end projectors measured parallel to the XY reference line happens to be 55 millimeter. So this is the vertical projector line corresponding to the projection of the point P. Similarly, there will be another vertical projector line corresponding to the projection of the point Q, irrespective of in which quadrant this point is going to lie. So the distance between the vertical projector of the point P and the point Q measured parallel to the XY reference line. Now we are required to measure this distance and plot this distance over here between the projection lines of the point P and the projection line corresponding to the point Q over here. So this vertical projector line now we can draw corresponding to the point Q. So now we are going to obtain the front view and the top view projections corresponding to the point Q onto this vertical projector line. Now this distance happens to be 55 millimeter as it has been indicated over here. Now let us work out the coordinates of the point Q with respect to horizontal plane and the vertical plane. So once we look at the coordinates of the point Q, that is point Q is located 30 millimeter below the horizontal plane and 40 millimeter behind the vertical plane. So it means that point Q happens to lie in the third quadrant, and whenever a point is lying in the third quadrant, so distance of that point below the horizontal plane will be represented as Q dash below the XY reference line into the front view projections, and the distance of this point behind the vertical plane, it will be projected above the XY reference line alongside the same projector line. Since this point Q lies 40 millimeter behind the vertical plane, so we have to plot this point Q above the XY reference line at a distance of 40 millimeter above the XY reference line. So point Q has been located. So wherever point Q has been located, point Q dash will be located onto the same vertical projector line. Now we have been provided with this information that point Q lies 30 millimeter below the horizontal plane. So the front view projection of the point Q onto the vertical plane will be 30 millimeter below the XY reference line. So in the third quadrant, front view is located below the XY reference line, while the top view has been located above the XY reference line. Now, having obtained the points P dash, Q dash, P and Q, so we are going to join the respective points in the elevation, that is P dash with Q dash and P with Q. So P dash, Q dash, it is the apparent length of the oblique line when point P lies in the first quadrant and point Q happens to lie in the third quadrant. Similarly, PQ, it is the apparent view projection of the line in the top view projections when point P is lying in the first quadrant and point Q is lying in the top quadrant. Now we are going to obtain the right hand side view projections of the points P and Q using this particular transfer line. So please see, the height of the point P dash and the depth of the point Q dash, they are not going to change even in the profile view projections over here. So whatever is the height of the point in the front view, so same height of the point P will be there, that is P double dash will be there even in the side view. So what we can do over here, from point P dash, we are going to draw a horizontal projector line which will be drawn at a height of 25 millimeter above the XY reference line. But here we can see that this distance, this is distance of point P from the vertical plane. So this distance we have to now transfer from the top view projection into the profile view projection over here. So we know that we have to use this transfer line. So please check, we have got this transfer line drawn at an angle of 45 degree with respect to XY or with respect to the X1, Y1 reference line. So from point P, we know that point P had been obtained at a distance of 10 millimeter from the vertical plane. So now this 10 millimeter distance from the vertical plane which has been obtained in the top view projection, this will be transferred, please see, using a horizontal construction projection line and extending it to intersect with the transfer line over here. So wherever it intersects with the transfer line over here, we have obtained a point corresponding to the point P, which is 10 millimeter in front of the vertical plane. And from this point, we are going to take a vertical projector upwards in such a way that this distance of 10 millimeter in front of the vertical plane from the top view will be transferred into the profile plane. And again you can check, because this is a transfer line at an angle of 45 degree. So this distance of 10 millimeter from the vertical plane into the top view has been transferred as 10 millimeter distance from the vertical plane into the profile view. So wherever this vertical projection line, it intersects with the horizontal projection line which was drawn through the point P dash, this intersection point will give me the point P double dash over here. Now I can check the coordinates of this point. So this point P double dash has been located, please check, in quadrant 1. So this is my quadrant 1 over here, and this is located 25 millimeter above the horizontal plane and 10 millimeter in front of the vertical plane. So let us now transfer point Q dash over here so that point Q double dash can be located into the side view projection. So as we have discussed, whatever is the distance of the point Q in the front view from the horizontal plane, so this point Q dash lies 30 mm below the XY reference line or below the horizontal plane. So onto the same horizontal locus line, the side view will be lying over here. That is, point Q double dash will be lying at the same depth over there. Depth means 30 millimeter below the horizontal plane. Now let us transfer this distance. So what does this correspond to? This point Q, it corresponds to the location of the point Q in the plan. And this distance is 40 millimeter behind the vertical plane. So this will be transferred onto the profile plane using this transfer line. So please check. So this is what we have been doing earlier also. So here this is our transfer line. So the distance from the vertical plane, which happens to be 40 millimeter behind VP, this will be transferred to the profile plane using this transfer line. So how this will be done? From point Q, we will be drawing a horizontal locus projection line. So this particular locus line, we have to extend this line in order to allow this line to intersect with our transfer line. A vertical projector line will be drawn through this point Q over here. So through this point Q, a vertical projector will be drawn and extended till it meets the horizontal construction line which have been drawn through the point Q dash in the front view. So this is the horizontal construction line drawn through the point Q dash. So wherever these two construction projector lines, they intersect, we will be obtaining the point Q double dash over here. Now if we check the coordinates of this point Q double dash, now you can check. This is 40 mm behind VP and 30 mm below the horizontal plane. So this belongs to the third quadrant, that is below the horizontal plane, behind the vertical plane. So this point represents the true location of the point Q in the third quadrant. So location of the point P in the first quadrant has been located. Location of the point Q in the third quadrant has been located. So P double dash and Q double dash, if we join both of them, so we are going to obtain the side view projection, that is right hand side view projections of the 2 points P double dash and Q double dash, which correspond to the line PQ, in which point 1, that is point P, happens to lie in quadrant number 1. Where does it lie? 25 mm above HP and 10 mm in front. So please check, 25 mm above HP and 10 mm in front of VP. And where does point Q lie? 30 mm below HP and 40 mm behind the vertical plane. So this way the side view projections, that is the right hand side view projections, have been obtained. The front view projections P dash Q dash have been obtained, and the top view projections PQ projections, they have also been obtained. So this way we have been able to obtain the orthographic projections of an oblique line in which the two ends of the line, they happen to lie in different quadrants. So point P was lying in quadrant number 1, while point Q of the line PQ, it was lying in quadrant number 3. So we can check over here, point P double dash, it is lying above HP and front of VP, so it is lying in quadrant 1, whereas point Q double dash, it is lying below HP and behind VP, so it is lying in quadrant number 3. So this is all for today. So I hope that through this discussion you would have understood about how do we locate the orthographic projections of a line when the two ends of the line, they happen to lie in different quadrants over there. So we'll be continuing with further discussion regarding few more illustrative examples of projections of the lines in the coming lectures. So thank you very much. Thanks a lot.